Hello, everyone. Welcome to SAT Math Practice on Sam's Math Tutorials channel. Today, we're going to be talking about linear equation systems or systems of linear equations, if that sounds familiar to you, systems of equations. And this is the lecture, so let's jump into it. You may be asking, what's a system of equations? Well, a systems of equations, a system of equations is a group of at least two equations that most of the time have multiple variables. So here's a few examples of some of them. As you see in the first one here, 2x plus 3y equals 5, and then 5x plus 4y equals 7. There's two separate equations, and it has multiple variables, and same with the yellow equations down here. So these both qualify as linear equation systems. The goal of these, when you're solving for them on the SAT, is to solve for both variables. And there's two different methods of doing that. One, substitution, which is when you solve one equation for a variable, and you're going to plug that equation into the other to get the variable's value, and then you plug this new value for the variable into one of the equations to get the other variable value. So it's a very long, tedious process that I don't really recommend, but I know some math teachers require that you know how to do it. And then there's combination, which is when you're going to add equations together with the goal of eliminating one variable and solving for the other. And this is the method that I highly recommend, especially if you're doing the SAT. But I just did an example of substitution. We're going to use the same system of equations for both the substitution example and the combination example, but I just wanted to show this to you. So here's how I started up here. So I am using this equation right here, and I'm solving for y. So I moved the 2x over to the other side, divided everything by 4 to get this equation. And then I plugged this back. I plugged the y equation into this equation here, down here. So then you have to multiply all of that out. You have to get common denominators, which is a pain. And then you have to add everything together, and then you eventually end up getting x equals negative 7 over 5. Then you're plugging that value into this equation down here. Then you're distributing, and you're adding, and you're dividing, and finally you get that y is equal to this. So it's a very long process, but here's an easier process, and this will make a lot more sense when you actually see me doing it. So we have these two equations, and the goal of combination, like I said earlier, you're trying to add both of the equations together while simultaneously canceling out one of the variables so that you could solve for the other. So here's what I'm going to do. I'm going to multiply the top by 7. So 7 times 2x plus 4y equals 6. I'm going to multiply the bottom by negative 2. So 7x plus 9y equals 10. And then all I'm doing is distributing. So we get 14x plus 28y equals 42. And then negative 14x minus 18y equals negative 20. So the 14s cancel out and the x's, so we just end up with the y's and the constants. So we get 10y is equal to 22, divide both sides by 10. Y is equal to 11 over 5. So we have the y value. And now all we're doing is we're plugging this into either one of the equations to solve for x. So I'll plug it into the top one. So 2x plus 4 times 11 over 5 is equal to 6. And distribute, so 2x plus 44 over 5. And I'm going to turn the 6 into 30 over 5 so that we can have common denominators here when we subtract. So we're going to subtract both sides by 44 over 5. So we get 2x is equal to 30 over 5 minus 44 over 5, which is negative 14 over 5. And we're going to divide both sides by 2. So we get that x is equal to negative 14 over 10, which is x is equal to negative 7 over 5. So This was the same system of equations for both, and we got the same answers for both. So it just goes to show you that combination is a lot more simple and it will save you a lot of time on the SAT. Here's just a couple of important facts that you need to know about linear equation systems. Whenever you have no solution, so when you get something like this, that means that there are parallel lines, that the two equations are parallel, which is symbolized by that. So it's like two lines that never intersect, like that. You're not going to get a solution for both of them. You're not going to find where they intersect on the coordinate plane. When you get one solution, that means that the lines intersect at a point. So that's pretty self-explanatory. And then when you get infinitely many solutions, so that means that it will look something like this: 0 equals 0. So all the variables will cancel out or something like that, and you'll get both sides equal to the same thing. There's no variables there. That means that both equations are the same. Just written differently. So, yeah, that's pretty much all you need to know. And in the next equation, we're going to be jumping into practice problems. So, I hope this video helped, and stay tuned for the next one.